Hello. All right, so we're going to be kind of starting on the beginnings of kind of creating unit circles and understanding the unit circles. To do that, we want to be able to convert between what we call radians and degrees. So most of you guys are really familiar with degrees. We've got this like kind of circle basically. We've got 0 degrees, 90 degrees. So just a couple things to know. The ray that is actually on the x-axis, so this side of my angle, whatever one is on the x-axis, that side is actually called the initial ray. So get that kind of put down there. Sorry about my spelling. All right, and then the other side, the side that creates this angle right here, this side right here is called the terminal side. So the side that's kind of sticking out, that'll actually be called our terminal side. So a couple little terminologies to get through, right? When you go clockwise, meaning you're heading in this direction, you have our positive degrees. So that's 0 degrees, and if you shot out here, there'd be a 45 degrees and 90 degrees. And as you can see, these all kind of go as you're going in this direction. So going from here to here, you're heading in a positive angle direction. So counterclockwise gives us our positive. If you go the other way, you're going to get negative degrees. So you could have like a negative 30. And if you're talking about a negative 30, you're saying he's kind of down here. All right, so that would be a negative degree, which basically means you're heading in that direction. So a couple things to kind of make note of. All right, and if you go once around this entire thing, so you go from the starting point here and you go all the way around and make it right back to here, that is actually 360 degrees. He is also, I'm going to put here so you know, when we get to radians, 2 pi. Means we've gone around the circle once. That's our 2 pi. All right, now that we have kind of the terminology, we have a couple little drawing ones for you. So starting off, where do you think 75 degrees would be here? So you could kind of come here and say, well, it's a positive, so that means I know I'm going to head in counterclockwise direction, so I'm going to head that way from here. And I would say he's, I mean, if this is 90 degrees, he's somewhere over here. You could put a line up here and say that would be roughly where this angle would be 75 degrees. All right. Look at number 2. Number 2, notice it says negative. What that means is I'm going to head in this direction instead. So this is 180 degrees. I know I'm not going to be quite there. So this is going to be roughly probably here is about where 160 would fall at that negative. And keep in mind it's negative because we're heading in that direction. So this is 160 degrees from this angle right here. That's the angle that gets formed. All right. And our last one, what's 430? Well, that's positive, so I know I'm heading in that direction. And I know that me going just once around, that's 360. And so then I can say, okay, well, what's left? Get up here, probably right around here, that would be 430 degrees. That's me kind of going around. All right, so kind of drawing a little bit of that. Let's get into our degrees and radians. So basically, 360 is us going all the way around. That would be considered 2 pi radians. If you're doing 180, that's halfway around, not all the way around. That would actually be pi. So it kind of helps you to know that on one side you have 2 pi, the other side's pi. Now when you want to convert, there's an easy way to convert, which is if you're looking for radians, you're going to take your degree times pi over 180. And if you want the degrees, you're given a radian instead, you're given 3 pi. You go 3 pi times 180 over pi. So again, this is a lot easier than it thinks. We're going to start first by getting degrees and switching them into their radians. So you could say, it's kind of like saying, you know, you can say the number 4, or you could say the number 8 over 2. That's still 4 as well. Well, degrees and radians, these are the same thing. So 30 degrees, what would be the radian equivalent? They would be at the exact same spot on the unit circle. So turning around, I was given degrees. So I would say, okay, well, I got 30 times, and then if I want to get the radians, I'm going to take the degrees times pi over 180. So I'm going to turn around here and say pi over 180. And that gives me 30 pi over 180. And I'm going to reduce this down. So 3 goes into 18 6 times. So this is pi over 6. So when we say 30 degrees, you can say 30 degrees or you can say pi over 6. Those are the exact same spots on our unit circle. All right, so let's have you guys convert. We're going to do 2 conversions. I'll have you do number 5. So just pause the video, give yourself a little bit of time, and then come back and I'll give you the answer. All right, so that should have hopefully given you some time, or at least you've paused the video. The answer for number 5 should have been 5 pi over 6. So that is the radian degree for number 5. All right, let's talk about number 6, negative 220 degrees, which just means I'm going the clockwise route, but it's still solved the exact same way. I'm going to turn around, I'm going to say negative 220 times pi over 180. That gives me negative 220 pi over 180. And then I'm going to reduce this fraction down. Remember, I don't want to reduce the pi out. He's going to stay there. And I should have gotten the answer negative 11 pi over 9. Get that pi back up there. So that's the radian degree. And notice he's negative as well because that means you're going in the clockwise rotation. All right, let's switch this around. Let's say, okay, I have these pi's. A lot of people like to take radians back into degrees because we're really comfortable with degrees. We're used to 30 and 60 and 45. They make a little more sense for us. So let's say I have this radian and I want to switch it back into degrees. That basically means that I'm going to take the radian, I'm going to times it by, and I'm going to flip it 180 over pi instead. All right. When we do that, we're going to go straight across. I'm going to say 4 times 180. I'll figure out what that is in a little bit. I have pi, and then I have a 3 pi. And I can already see these pi's are going to cancel off, which is what I wanted because I don't want that. And then you can reduce down if you want from here. You know, you can go 3 into 180. You're going to multiply and divide. Either way, get your calculator out, times that, divide it by 3, and that should have given you 240 degrees. So 4 pi over 3 is roughly 240 degrees on a circle. All right, have you try number 8 and 9, and we'll come back and get those answers. So again, please pause the video just for a second, get your answers, and let's see if you get to the right answer. All right, hopefully you had some time. You paused the video. You should have come to negative 25 degrees for number 8. And for number 9, again, if you haven't paused the video, pause it, do number 9. If you have, the correct answer should have been 315 degrees for number 9. All right, so that pretty much covers the conversion part. Turn to the next page, and we're going to kind of talk about this circle. So again, keep in mind, we're going to have coterminal angles, kind of how we're going to look at things. Give me 1 second. All right. Sorry about that. I had to run and go grab the calculator. So the next thing we're talking about is the coterminal angles. So what that basically is when we have an angle, let's say we're looking at this angle right here, it's 30 degrees. You can have, if they kind of come back to the same spot, they're considered kind of coterminal angles. So what I mean by that is you have this 30 degrees. I could take this 30, go another 360 degrees and end up in the exact same spot. So if I took that 30 and added 360 to it, the 30 degrees and the 390, both of those angles are the exact same angles. One's just looping the circle once. I could also go the other way. I could turn around and say, okay, well, if I took the 30 and went backwards 360, so I went from here and I went around, I would end up at the exact same spot if I do another circle going the other way, and that'll give me my negative version of this. So that would be negative, what is that, 330. So these angles, 390 and negative 330, those are considered coterminal angles. One's the positive, one's the negative version of it. So let's kind of try one. Let's say I was at 65 degrees and I wanted to find both the positive and a negative version of this. So what I could do is I just turn around and say, okay, well, if I took the 65 and I went a full circle in front, I'm going to be at the exact same 65. So 65 plus 360 gives me 425 degrees. That's my positive one. If I want the negative, that would be me going backwards. So basically, you know, doing a full circle going the other way. So I just take my calculator, 65 minus 360 gives me negative 295. These are considered their coterminal angles. They're basically the same angle, you're just moving ahead, 360 degrees. All right, let's have you try number 11. Again, pause the video, find the two, both a positive and a negative coterminal angle to 540. All right, welcome back. So 540 is kind of a little trickier. He was already in the forward motion. So I would have, I would subtract 360 from this to get back to his original one because he's already gone past 360. And that would have given me 180 degrees. So there's one positive version of it. At that point, I know basically, if I want to come back up here, I'll show you this. 180 degrees is this angle right here. It's basically a straight line, right? That's the 180 degrees. If I went from here to here. So if I wanted to do one and go into the negative direction, going from here to here, so I'd do from this going this way, I could take the 180 and minus 360 from that, and that'll give me the negative 180. 180 is kind of a tricky one. So if you didn't get that one, I understand, but I would definitely practice it. I would assume a lot of you guys went 540 plus 360, and you're right, that would be a coterminal angle, but you're just making it bigger. Sometimes it's easier to try to get the numbers closer or less than 360 if they're not. All right, that'll make it a little easier. All right, what happens when we're looking at radians? Well, radians, I'm going to still add 360, but keep in mind that 360 degrees in radians is 2 pi. So I'm going to add 2 pi to this. So I'm going to come to this first one, 13 pi over 18, and I'm going to add 2 pi to it. Well, to add 2 pi to that means I'm going to turn it into a fraction. You guys kind of hopefully know where this is kind of headed. I'm going to get common denominators. So my denominators would be 18. So I have 13 pi over 18 plus 36, I believe, pi. I times that. Yep, 36. And then I can now add my numerators. So 13 plus 36 gives me 49 pi over 18. Oh. Okay, having a little trouble there, so let me pull that up to the top. So over 18. So that is one of my answers. That's the positive one. To do the negative one, that would be me taking the 13 pi over 18 minus 2 pi instead. Good news is it's still at least the same common denominator. So now I'm just going to minus the 36 over 18. Then again, I go 13 minus 36, which gives me negative 23 pi over 18. So there's the positive version, and there's the negative version. All right, let's have you try one. We'll have you do number 13, and we'll come back and see what you get as answers. So go ahead and pause the video. All right, hopefully you have plenty of time to get your answers. So you should have had it plus would be 32 pi over 9, and the minus would be negative 4 pi over 9. So again, those angles would still be the exact same angles. One is just kind of going forward one loop, and one is going backwards one loop. So that's what coterminal angles are. All right, let's move on to reference angles. All right, so a reference angle is probably what you're going to use the most in creating a unit circle. So again, we have this circle. This is, of course, our 360 or our 2 pi. This is our 180 or our pi. And you usually kind of get these memorized. You should. This is 90. As a radian, you can convert that 90 into it. You should have pi over 2. Just some things that you should kind of have memorized. This is, I think, 270 degrees. You add 90 to that, that should equal that. And this should be, I believe, 3 pi over 2. All right, so those are some basic, this is kind of the beginning of a unit circle if you look at it. All right, when we're talking about reference angles, they will help us out the most in a unit circle. So a reference angle is, if we have this angle, let's say we have an angle shooting out here, all right? And this original angle from here to here is, let's say it's 100 and, I don't know, 120. Just make that 120. The reference angle is this other side, this acute angle that is made to this x-axis. So this angle is kind of the reference angle, so this would be 60 degrees. So we're going to use 60 degrees when we're over here. That's going to help us create these points on this unit circle. So knowing the reference angle is very helpful. That's the one that kind of helps us to decide what things are. So again, if you have an angle, the other angle that goes to the x-axis, this one is considered the reference angle, so the shortest route there. All right, let's get a couple practices on reference angle. Sorry, I have to erase that bottom one, but it gets a little close. So let's say we have number 14 is looking at an angle of 225. Well, I can look up here, I already know I'm going to go past the 180. So I'm going to say, I'm going to kind of shoot out this angle right here. From here to here is roughly 225. All right, his reference angle is not going to be this one. That would be over that. We want to keep the reference angle between 0 and 90. So this reference angle is right here. That's the shortest, the smallest acute angle. So I'm looking at this angle here. What would that be from 180 to the 225? And if I look at that, that would be 45 degrees. So our reference angle is technically 45 degrees, if that makes sense. All right, let's try the next one, 15. So this is negative. Remember, that means we are going in the opposite direction. So me going this way, and I'm going to go past pretty much all of this, and I'm going to go up to 310. And come here. That's this angle right here. This is negative 310 degrees. Now, the smallest angle I see here is this one right here. Goes across the x-axis. I have to be connected to that. That would be this angle. That would be a bigger one. So I want the smaller one. This is his reference angle. And this would be at roughly 50 degrees. So that's an angle of 50. And our final one, what happens if it's in radians? Well, I'll be honest with you, if it's in radians, I would probably convert this into degrees so I can kind of see the degrees. And then once I get the degrees, I'll convert it back into radians. You'll see me kind of doing conversions both ways. So the first thing is I'd be like, okay, well, what is this as a radian? There is a way to do it if you're comfortable with radians. But right now you need to convert anyway, so let's just practice it. So that would be me timesing 180 over pi. This would give me, the pi's would cancel off. This is 60 times 2, which is 120 degrees. So 2 pi over 3 is roughly 120. So that's really this angle right here. That's roughly 120 degrees. I'm going to put this as 2 pi over 3. That's what that is. And then his reference angle, again, I have to be connected to the x-axis, either the right-hand side or the left-hand side, and I want the smaller angle, this angle right here. So that's 180 degrees minus the 120, 6, that gives this is 60 degrees. So his reference angle is 60 degrees. So I'm going to convert that 60 into radians because I started with radians. So I'm going to go 60 times pi over 180. Gives me 60 pi over 180, which is pi over 3. So his reference angle is pi over 3. So when we're looking at 2 pi over 3, you're going to see when we start creating the unit circle, I'm going to use the points that relate to pi over 3 to create 2 pi over 3. There'll be just some sign changes that I do. All right, I know that seems kind of weird. Practice it. You will get familiar with it. Our last two things are to kind of go back to trig, and we're finally going to use a little bit of it to kind of help us out. So I know Pythagorean theorem, a squared plus b squared equals c squared, is super popular, but technically Pythagorean also had another one that they used that dealt with the unit circle. So this is kind of where that a squared plus b squared kind of comes about. But if we look here, here's this one side, which we would say x squared plus, here's our other side, y squared. equals, again, the hypotenuse squared, the radius right there. So we can also use that. So we will be going kind of back to this to help us solve things, just so you know. But for right now, we can use our trig functions to find things as well. So when we're looking at this, which I know seems kind of weird, but when we look at this, we got this is our angle right here. This is opposite. This is hypotenuse, and this is adjacent. So when we're doing this and filling this stuff out, hopefully you can fill this out really quickly. Sine is opposite over hypotenuse. So opposite would be y over r. If we turn around here, our cosine is adjacent over hypotenuse, so x over r. Our tangent is going to be opposite, y over adjacent, x. And then these are, remember, the inverses, which is basically them being flipped. So our cosecant is going to be hypotenuse on top, so r on top, over secant is going to be hypotenuse on top over adjacent, and cotangent is going to be adjacent over opposite. I can get through all those. So filling those in should be really easy. All right, so that's kind of where we're going to kind of get measurements, and now we're going to use the unit circle to kind of help us solve for things. So this says we have a point at positive 5, 2. So this is a coordinate plane. If I go to positive 5, that would be me going like this. 1, 2, 3, 4, 5. And then it's down to 1, 2. That's that point right there. That's at 5, negative 2. This, I'm going to try, actually, let me use my line tool because I want to make sure I get it. Creates an angle. I'm going to put it right there. I should have done it in red. Oh, never mind. Let me undo that. Leave this off a little. Okay, it will not let me undo. So let me delete. Sorry. So we have this line that's kind of going through this. I'm going to create that triangle that we're going to see. We know that this distance was 5 and this distance is negative 2. That we do know. Here's our angle, as you can see, where we're going to get into trig functions. And the first thing I'm going to do is I'm going to find the hypotenuse, because I can see down here I'm going to have to find all of my trig functions based on this. So the hypotenuse, remember, is our a squared plus b squared equals c squared. So I'm going to turn around here and go 5 squared plus negative 2 squared. Notice I put that in parentheses because that negative is getting there. Equals what I'm looking for, that r squared. I'm looking for that hypotenuse right now. So I start solving this. This gives me 25 plus 4, which gives me 29. And r squared is the square root of 29. It does not simplify any further, so I'm going to go ahead and put this here. It does mean I will have to rationalize denominators at times. All right, so now that I got my 3 sides, I can go ahead and find my sine, cosine, and tangent. So let's go ahead and label this. The negative 2 is considered opposite. The 5 is adjacent. And we just found the hypotenuse, which was square root of 29. So sine is opposite. So negative 2 over hypotenuse, 29. Again, I got to rationalize denominators. I cannot have a radical on the bottom. So I go ahead and just multiply it, put it up at the top. And that gives me negative 2 square root of 29 over 29, which is my final answer. It doesn't reduce down any further. The cosecant is basically flipped. So it is my hypotenuse, which was the square root of 29, over opposite, which was negative 2. And in this case, the radical is on the top, so he's done. All right, going over to cosine, that would be adjacent. So that is 5 over hypotenuse, which is square root of 29. Again, I will have to rationalize this. So I'm going to multiply by square root of 29 on both the top and bottom. That way he's not on the bottom anymore. He gets to come out of the house. And up at the top, there is no simplifying. I can't cancel these off. 29 is a prime number, so it's pretty much done. Cosecant is me flipping it. So basically, this would have been square root of 29 over 5. I do not have a radical in the bottom, so I don't need to worry about him. Finally, we get to our tangent and cotangent. Tangent is opposite. That's negative 2 over adjacent, which is 5. And that is done. Don't need to simplify that any further. And the cotangent is basically the flip of it. So it would be the 5 over the -2. So easy enough if you remember how to kind of create this. So you'll find a point, find the length, the width, sorry, the length, and then the height, and then use Pythagorean theorem to help you find out that hypotenuse. All right, I hope this helps, and start on your homework.